All right, for this lesson, you're going to need your periodic table and a calculator. And what we've calculated so far is average atomic mass, which is the small number at the bottom of each symbol right here, okay? And what we've been using so far is just the average of all the isotopes. But those also are something called grams per mole as a unit, okay? And what that is saying is that there is 1.0079 grams in 1 mole of hydrogen, okay? And so we're going to need this throughout the year. So this is very important that you understand how to calculate molar mass, because we will be doing it, I promise you, for the rest of the year. Whenever we're taking the masses off of the chart, we're always going to round them to 2 decimal places. So the ones we have listed here, carbon, would become 12.01 grams per mole. And then if you look at copper, this 4 would be rounded up by the 6 that comes behind it, so it would be 63.55 grams per mole. And then hydrogen would become 1.01. And so that's the way you round those. You just have to look and see what comes behind that second decimal place and see, does it round it up or does it stay the same? Okay, so here's some other examples to look at. We already did carbon, becomes 12.01. If you look at an aluminum, it's 26.98, so that 2 does not round it up, so it becomes 26.98, stays the same. And then, of course, zinc only has 2 decimal places, and you'll see a few of those like that on the table, and we just write that down as 65.39. So now that we understand how to round the 2 decimal places, and I will have to repeat this, I'm sure, several times in class, but you will always round the molar masses to 2 decimal places. Now let's talk about how we find the molar masses of compounds instead of just the individual elements. The way that we do that is we simply add all of the compounds' molar masses together, and then we round that final answer to 2 decimal places. So let's start with water, and for some reason when I pulled this PowerPoint into this program, it took all the subscripts and made them big, so let's make sure you understand that it's H2O, okay? And so what that is saying is that I have 2 hydrogen and 1 oxygen. So I'm going to go look at my molar masses. If I take hydrogen, it rounds to 1.01, and since I have 2 of them, I'm going to say 2 times 1.01 plus, and that's important because if you multiply these together, you will get a super big molar mass, which won't be correct, and then plus oxygen. If I look at oxygen, it's 15.9994. So I'm looking at that last decimal place right there, and if you see, there's a 9 that comes behind it, so we'll actually round that to 16. And then when I add those together, you get 18.02, which is the molar mass of water. And I promise you by the end of the year, or actually probably fairly quickly, you will have that number for water memorized because we use it so much. And now let's look at sodium chloride. If you look at sodium, it's 22.990, so we will write that down as 22.99. If you look at chlorine, it's 35.45. That 3 does not round it up, so we use 35.45, and we add those 2 together. Remember, we're adding, not multiplying, and we get 58.44 grams per mole. All right, let's do a couple of more. Again, this PowerPoint likes to change things on me, so it's NaHCO3. Okay, and when you see these subscripts like this, they only count for the element that they are right behind. So they only count for this oxygen here. Okay, so I look at my sodium. I have sodium is 22.99, so I write that down there. My oxygen, my hydrogen, excuse me, we said was 1.01, so that's there. And then we have 12.01 for carbon, and then remember, oxygen rounds to 16, and since we have 3 of those, we do 3 times 16. And so I add all of those up, and this would be a good time to pause and add it in your calculator to make sure that you're getting the same answer as I am, and you should get 84.01. And again, the units for the molar mass are grams per mole. They can also sometimes be AMU in certain things, which stands for atomic mass unit, but we will almost always exclusively use grams per mole. All right? So the next compound we're looking at, and it kind of overlapped, is sucrose, which is table sugar, and it actually is written C little 12, H little 22, O little 11. Okay? I'm not sure why this program did that, but it did it across the board. So again, we got 12 carbons, so we have 12 times 12.01, which we got from carbon right there, plus 22 hydrogen, which is times 1.01, plus 11 times 16 for oxygen. And again, you might want to pause, add it in your calculator, and see if you also get that 342.34 grams per mole. And so what I want you to to understand here is this is going to be at some point used as a conversion factor, as grams per mole. Remember, anytime we have something per mole or per anything, it's always one of them. So this is the same thing as saying 342.34 grams of sucrose is equal to 1 mole of sucrose. It would be the same amount, kind of like 12 inches in a foot. And so we will use this as we go along as a conversion factor. All right, so now let's try 2 of them on our own. And these are in your notes, if you're following along, hopefully in your notes. They're at the bottom of the page. And so we're going to do first something called ammonium sulfate. And let me write the formula down here because it's kind of overlapped. And again, they did that whole thing with the subscript. And whenever you see a formula like this that has parentheses, and then something inside the parentheses, and then a subscript, what that means is this 2 goes for everything inside of the parentheses, okay? So what we really have here is we have 2 nitrogen, and we have 4 times 2, we have 8 hydrogen, okay? Still only 1 sulfur, and then of course the 4 oxygen, all right? So now let's do that all together, and as we put this on here, you might want to pause, because I go a little faster than sometimes you guys do. So we're going to add that all together. So I'm going to say 2 times the nitrogen, which is 14.01. And then I'm going to say plus, I had 8 hydrogen, which is 1.01, plus 1 sulfur, which if we round sulfur becomes 32.07, plus we had 4 oxygen, times the 16. So now we want to add that all together in your calculator. And again, if you need to pause it, go ahead. And what you should come up with is 132.17 grams per mole. And remember, that's the same thing as saying that for every 132.17 grams of ammonium sulfate, it is equal to 1 mole of ammonium sulfate. Okay, last one. This is dichlorine heptaoxide, and we're going to do this Cl2O7 little subscripts just so we make sure we understand that. And so I have 2 chlorine, so I will start with the 2 chlorine, and it rounds to 35.45 plus 7 oxygen, which is, we said 16. And when we do that math, again, pause if you need to, you should get 182.90 grams per mole. And remember, that's the same thing as saying 182.90 grams is equal to 1 mole. And so that's the last one we're going to do today. And if you're having trouble understanding it, you might want to go back and rewatch the video, or honestly, just practicing this over and over is something that you should do. Now, I want to just remind you that when you have something like this and you have a subscript outside of parentheses, that subscript goes for everything inside there. So in other words, you would have 3 sulfur and you would have 4 times 3, 12 oxygen. So just want to remind you of that as you go through your homework, that you understand that. And of course you would have the 3 aluminum, because when it's not a parentheses around it, it only counts for what it comes right behind. All right, as promised, I'm going to end the lesson with a joke. So we're going to go old school and do some knock-knock jokes. So I hope you're ready. Knock, knock. Little old lady. I didn't know you could yodel. All right, next one. Knock, knock. Tank. You're welcome.